In a time when American muscle ruled the roads, a daring experiment ignited a spark of innovation that would challenge tradition and push the limits of engine technology. The Oldsmobile Jetfire burst onto the scene in the early 1960s, promising a future where compact cars could pack the power of larger, heavier engines. Wrapped in a sleek, hardtop body and adorned with distinctive chrome accents, it carried an aluminum V8 engine fitted with a turbocharger, a revolutionary turbo rocket that produced impressive horsepower and torque. Yet, behind its bold exterior lay a complex and delicate system. The car used a unique water and methanol injection to cool the forced induction charge, a feature that perplexed many drivers and mechanics. As the first American production car with turbocharging, the Jetfire offered thrilling performance, but also warned of the perils of premature innovation. The Oldsmobile Jetfire was born from the Oldsmobile F85, a compact car built by the Oldsmobile division of General Motors in the United States. Introduced in 1961 as a part of a new wide-body platform shared with the Buick Special and the Pontiac Tempest, the F85 represented a new approach to smaller, economical vehicles. In an era when large, naturally aspirated V8 engines reigned supreme, Oldsmobile's engineers sought to change the rules by installing a turbocharged engine in a compact package. Working closely with Garrett A. Research, they developed a turbo system based on a small-diameter Garrett T5 turbocharger with an integral wastegate. This unit was fitted to an all-aluminum 215 cubic inch V8 engine, an engine originally designed by Buick that would later evolve into the famous Rover V8 in Britain. The turbocharged engine, known by the name Turbo Rocket, was rated at 215 horsepower using the gross measurement method and produced 300 pound-feet of torque at 3,200 revolutions per minute. To achieve these numbers, Oldsmobile increased the engine's compression ratio to around 10.25 to 1. However, when an engine is forced to work under such high compression, with extra air being pushed in by the turbocharger, there's a significant risk of detonation, a dangerous condition where the air-fuel mixture explodes prematurely inside the cylinder. To prevent this, engineers designed an innovative fluid injection system that sprayed a carefully measured mix of distilled water and methyl alcohol into the intake airstream. This mixture, known as turbo rocket fluid, was intended to cool the incoming charge, thereby reducing the likelihood of engine knock. Despite its technical brilliance, the fluid injection system soon became the Jetfire's Achilles heel. The system was mechanically complex, involving a series of hoses, floats, and valves that regulated the amount of cooling fluid introduced into the engine. Many drivers found the system confusing. If the fluid reservoir was allowed to run dry, a problem that occurred frequently because the fluid was an extra maintenance item, the system would automatically limit boost pressure. This protective measure caused a sudden and dramatic loss of power that frustrated many owners. Over time, dealerships often converted the turbocharged cars back to a conventional setup by removing the turbocharger and replacing it with a standard 4-barrel carburetor and exhaust manifold. In effect, what had once been an emblem of cutting-edge technology became a cautionary tale of an idea ahead of its time. The Jetfire was available only as a pillarless, hardtop coupe. Its body featured distinctive brushed aluminum side trim and unique chrome accents on the hood, which included 2 chrome fins that set it apart from its contemporaries. Inside, the car was outfitted with bucket seats and a center console that housed a special gauge. This gauge displayed a green band labeled Economy and a red band labeled Power, giving drivers an indication of when the turbo system was in full action. A small warning light would also signal if the turbo rocket fluid level fell below a critical level, alerting the driver to the need for a refill. Priced at roughly $3,000, about $300 more than the non-turbocharged F85 models, the Jetfire was marketed as a high-performance option for buyers willing to pay a premium for advanced technology. In terms of performance, early tests of the Jetfire were promising. Press reports noted that the car could accelerate from 0 to 60 miles per hour in roughly 8.5 seconds when equipped with a manual transmission, a time that was competitive with many larger, full-sized muscle cars of the era. The 3-speed automatic Hydra-matic transmission was also available, though many enthusiasts preferred the sharper response of the manual gearbox. Despite these encouraging numbers, Real-world testing often revealed a discrepancy between the theoretical performance and what drivers experienced on the road. Many testers found that when the turbo system's fluid injection was not properly maintained, the car's power would suddenly drop as the system forced the boost to a safe, low level. This inconsistency undermined the car's reputation and contributed to its relatively short production run. Oldsmobile produced the Jetfire for only 2 model years, 1962 and 1963, with a total production of roughly 9,600 units. In 1962, about 3,765 Jetfires rolled off the assembly line, and the following year, sales improved slightly with around 5,842 units produced. Although these numbers were modest compared to the sales figures for the standard FI-85 and Cutlass models, the Jetfire quickly became a collector's item. Today, only a small number of Jetfires remain in good, drivable condition, and they are prized by collectors for their historical significance and unique engineering. Despite its technical flaws, the Oldsmobile Jetfire played an important role in the evolution of turbocharged engines in passenger cars. In the early 1960s, the idea of using forced induction to improve the performance and efficiency of an engine was still in its infancy. The Jetfire, with its bold approach and advanced engineering, helped pave the way for future developments in turbocharging. Later, other manufacturers refined the concept with electronic engine management systems, intercoolers, and more reliable turbocharger designs. In many ways, the Jetfire was a precursor to the modern turbocharged vehicles that now populate the roads, a reminder that innovation often comes with risks and growing pains. The design and engineering challenges faced by the Jetfire's creators were not unique to Oldsmobile. At the time, the entire automotive industry was grappling with the dual demands of improved performance and better fuel economy. In the wake of rising fuel prices and growing environmental concerns, automakers were forced to explore new technologies. Turbocharging offered a tantalizing promise: the ability to extract more power from a smaller engine without significantly increasing fuel consumption. For Oldsmobile, this meant that the same lightweight, high-revving V8 engine could deliver performance comparable to much larger engines, provided that the turbo system worked as intended. Names such as Gilbert Burrell, who served as one of Oldsmobile's chief engine development engineers, became associated with the cutting-edge research behind the turbo rocket engine. Collaborations with companies like Garrett AI Research brought advanced technology from the aviation and industrial sectors into the automotive realm. Additionally, figures like Jim Knoll, a dedicated restorer and advocate for the Jetfire, have kept the legacy of this pioneering car alive among enthusiasts. These individuals and companies contributed to a spirit of innovation that, while not always successful at first, laid the groundwork for future breakthroughs. The dimensions of the Jetfire were well suited to its role as a compact performance car. With a wheelbase of 112 inches, an overall length of 188.2 inches, a width of 71.6 inches, and a height of 52.7 inches, the car was nimble and easy to maneuver. Its curb weight was approximately 2,860 pounds when equipped with the Hydromatic automatic transmission, a weight that was low enough to contribute to its brisk acceleration, but heavy enough to remind drivers of its American muscle heritage. Over time, as new generations of engines emerged and turbocharging technology matured, the lessons learned from the Jetfire became invaluable. Engineers and designers studied its successes and failures to refine the art of forced induction. Modern turbocharged engines now rely on electronic controls, intercoolers, and a host of sensors to ensure optimal performance and reliability, technologies that were simply not available in the early 1960s. In many respects, the Jetfire can be seen as a prototype that paved the way for the advanced systems used in today's performance cars. Its legacy lives on in every turbocharged vehicle that hits the road, even as collectors and historians remember it as a bold but troubled experiment.